Please join me in exploring the beauty of mathematics around the world. Our first stop, San Francisco, California. No traveler to San Francisco lives without checking out the stunning views along the Golden Gate Bridge. The iconic red-orange suspension bridge rises high above the San Francisco Bay. So now we're gonna go to the tour. This famous landmark attracts visitors from around the world with panoramic views of the Pacific Ocean, the Alcatraz, and San Francisco. Find the length of the cable used in the diagram on the left. So since you're given a right triangle and the two sides are given, so we can solve for the length of the cable by using the Pythagorean Theorem. In this diagram, the missing side is the hypotenuse. So we will set up the equation as x squared is equal to 152 squared plus 642 squared. So now using your calculator, plug in 152 squared, and that gives us 23,104. And 640 squared, we have 409,600. And then we will just add the two numbers. And that will give us 432,704, which is the value of x squared. So now we need to get the square root to both sides. And the square root of 432,704 is 657.8. So the length of the cable used in this diagram is 657.8 meters. Challenge you to score 7 out of 7 in 7 minutes. For this video tutorial to be effective, I will be using this format. 1. I will flash each question for 10 seconds, and you may pause the video whenever you want to try out the problem. Next, I will explain each and give you some strategies on how to deal with specific questions. Are you ready? Here we go. Question number 1. Find the length of segment BC. So since side BC is missing, I will label that variable x. The first thing that you need to do is always identify what's given in the right triangle. So here there is a 70-degree angle. And from that 70-degree angle, you need to identify whether the side given is opposite, adjacent, or hypotenuse. And I suggest to always identify the hypotenuse first, because hypotenuse is always across the right angle. So the 5 here is your hypotenuse. And x is the adjacent or next to the 70-degree angle. So now we have the sides adjacent and hypotenuse. Try to recall the trigonometric ratio. So using the mnemonic SOH CAH TOA, that means we're using cosine function. So here we have cosine, the degree is 70-degree angle, and adjacent is x, hypotenuse is 5. Cosine 70 is the same thing as cosine 70 over 1, and you can cross multiply. So x times 1 will give you x, and you multiply 5 times cosine 70, that becomes 5 cosine 70 degrees. Now using your calculator, let's plug in 5 cosine 70 degrees. Make sure that your calculator is in degree mode and not radian. So we have 5 cosine 70 degrees. So the answer is 1.71. Question number 2. Find the length of segment AB. So AB is missing. I will also label this as x. Now, in reference to the 23 angle, we also need to identify whether you have opposite, adjacent, or hypotenuse. What do you think? X is the hypotenuse, and 3 is opposite or adjacent? Opposite, right? Because that is across the 20-degree angle. Now, which trigonometric function involves opposite and hypotenuse side? Sine, right? So we're using the sine trig ratio. So sine 20 degrees is equal to opposite over hypotenuse. So opposite is 3, and hypotenuse here is missing, so we have x. Same thing, we can put over 1, and then we cross multiply. So in this problem, if you multiply sine 20 times x, that's same thing as x times sine 20, and is equal to 3 times 1 will give you 3. So now to solve for the x, we can divide both sides by sine 20. That way we can isolate the variable x. So this will cancel out. You now have x is equal to 3 divided by sine 20. Now using our calculator, let's plug in 3 divided by sine 20. So the answer is 8.77. Question 3. Find the length of segment BC. Same thing, I will label x. Which function do you think we need to use? Tangent, right? Tangent because 7 is adjacent to 65 degrees and x is the opposite. And the trig ratio that involves opposite and adjacent is tangent. So to set up the equation, we have tangent of 65 degrees is equal to the opposite, which is x, and adjacent, which is 7. So the same thing, we can cross multiply. X times 1, we have x. 7 times tan 65. You write it 7 tan 65. So now plug it into your calculator. We have 7 tangent 65 degrees. So the answer is 15.01 units. Question number 4. Find the length of segment AB. Again, I will label that x. For this problem, which trigonometric ratio are we using? Sine, right? Because 4 is the opposite and x is your hypotenuse. So sine involves opposite over hypotenuse. So to set up the equation, we have sine 35 degrees is equal to opposite 4 divided by hypotenuse x. Again, put a 1 so you can easily see the equation. So now we have x times sine 35 is equal to 4. What's the next step? Divide both sides by sine 35. So dividing both sides by sine 35. Now let's plug in. We have 4 divided by sine 35 degrees. So the answer is 6.97. Question 5. Find the length of segment AB. Segment AB is a hypotenuse. So which function are we using? Cosine, right? Because 2 is adjacent to the 50-degree angle, so we're using cosine. Using cosine 50 degrees, the right side will be adjacent is 2 and hypotenuse is x. So now we cross multiply them. So we have x times cosine 50 is equal to 2. Next step is dividing both sides by cosine 50 because we need to isolate the x. So x is equal to, this cancels out. Now we need to plug in 2 divided by cosine 50. Plugging it in, we have 2 divided by cosine 50. So the answer is 3.11 units. Question number 6. Find the length of segment AC. I'll label that x. So in this problem, which trigonometric function are we using? Sine, right? Because 7 is the hypotenuse and x is the opposite of 40-degree angle. So how will you set up the equation? We have sine 40 degrees is equal to opposite over hypotenuse 7. So again, by cross multiplication, we have x is equal to 7 sine 40 degrees. Now we need to plug in 7 sine 40 degrees, and that gives us 4.50 rounded off to 2 decimal places. Question number 7. Find the length of segment BC. In this problem, we have 6 is hypotenuse and x is the adjacent to 35 degrees. So adjacent and hypotenuse, what trigonometric ratio are we using? Cosine, right? So the equation will be cosine of 35 degrees is equal to adjacent x divided by hypotenuse 6. So we have now x is equal to 6 cosine 35 degrees. Now let's plug in 6 cosine 35 degrees. So to get the value, we simply use calculator to evaluate 6 cosine 35 degrees. And that gives us 4.91. Here are the answers. Did you score 7 out of 7?